So this module will address some of the impact of distributed generation on other important parameters in the design of this distribution system. The voltage along feeder, here the impact of distributed generation is more directed, and the hosting capacity might be 0 in some case. As we will discuss in this chapter, the hosting capacity, which is strongly dependent on the choice of the performance index on a module that is used to estimate the impact that is causing on our distributed generation. Moving on. Here the structure of this module is similar to that of previous module, which provides a general overview of the way in which the distribution generation impact this voltage magnitude variation. An overview of various methods that allows more distributed generation to connect to this system, rather than a simple but a general method of estimating this hosting capacity is deterministic method, and it is stochastic equivalent. The design of distribution feeder without and with the distributed generation employs the model of the feeder, which allows to study the impact of these different parameters such as the location of generators on hosting capacity, etc. An alternative method for describing this design of this distribution feeder is followed. So in this method, less suitable for a steady real feeder, but it will allow us a better insight to impact the different parameters. The method shows to be an especially useful for calculating the hosting capacity for small generation, which spread over other customers. Tap changes with line drop compensations are discussed here in this module, and the probabilistic method of designing the distributed feeders is also discussed. Here the one of the main concern is the voltage imbalance. So the voltage imbalance is also called as the voltage unbalance. Sometimes it is also referred as the maximum deviation from the average of three-phase voltage or currents divided by a average of three-phase voltage or a current, which is expressed in percentage, usually imbalance. So imbalance is more rigorous. It will define the standards by using symmetrical components. The ratio of either the negative or zero sequence components to positive sequence components can be used to specify the percentage of unbalance. So key point, note that here the percentage of unbalance can be specified with the ratio of either negative sequence components to positive sequence components. The most recent standards specifies that a negative sequence method can be used. So the primary source of voltage balance of less than 2% in a single phase load on a three-phase circuit. So the voltage unbalance can also result in blown fuses in a single phase or a three-phase capacitor bank. A severe voltage unbalance can result in a single phasing condition. Whenever this severe voltage unbalance are caused, whenever the percentage is greater than the 5%. Coming to the voltage fluctuation. Voltage fluctuations are schematic variation of this voltage or the random voltage changes. So the magnitude of which does not normally exceeds the voltage range which is specified by ANSI. So 0.9 to 1.1 per unit. According to IEC 61000 defines various type of voltage fluctuations. Among that, a type D voltage fluctuations which are characterized as a series or random or continuous voltage fluctuations. The load that can exhibit the continuous or rapid variation in the load current magnitude can cause the voltage variations. So they are referred as a flickers. So the term flicker is derived from the impact of voltage fluctuations on lamps, such as which are perceived by our human eye. So there will be flickering effect on and off. So hence it is referred as flickering, voltage flickering. To be technically correct, voltage fluctuation it is an electromagnetic phenomena, while flickering is undesirable, which results in fluctuation of voltage in some load. However, the two terms that are often linked together in the standard, so therefore we will also use the common term, that is voltage flicker, to describe such fluctuations. So consider one example, like if it is a voltage fluctuation is caused in an arc furnace. One of the most common cause of voltage fluctuation in a transmission and distribution system. So the flickering signal is defined by RMS magnitude, which is expressed in percentage of this fundamental value. So if voltage flicker is measured with respect to sensitivity of human eye, typically the magnitude will be 0.5%. So this can result in a perceptible lamp that flickers if the frequencies are in the range of 6 to 8 Hertz. Then IEC, according to this IEC 61000, which defines the methodology specification of instrumentation for measuring this flickering. So IEEE voltage flicker working group has recently agreed to adopt these standards. They amended for 60 Hertz, so which is currently used in our North America. So these standards deviates a simple means of describing the potential for visible light flickering through voltage measurements. Measurements methods simulate the lamp, eye or a brain, which transfer function and produces fundamental metrics that is called as short-term flickering sensation, that is referred as PST. So one more important MCQ question here, guys. In general, not exactly from this module, but in general discussion with this voltage magnitude variation. So the measurement method that simulate lamp or even our brain to transfer function and which produces fundamental metric, it is called as dash. So short term flickering sensation, it is represented by PST. And so this value PST is normalized to 1 to represent a level of voltage fluctuation, which may sufficient to cause a negotiable flicker to 50% of sample observing group. So another measure called as long-term flickering sensation is often used for this purpose, to verify this compliance with compatibility levels, which are established by our standard bodies and currently which are used by utility power contracts. So this value is a long-term average of PST samples. So now current trend of this PST measurements that takes at a 161 kV substation in a bus where serving arc furnace load. So here the PST samples are normally reported at 10 minutes of interval. A statistical evolution process is defined to measure the standard, which possesses an instantaneous flicker. So measurement to the production that the PST values, the PIT value is produced every 2 hours from the PST values. Not only this, but various the most of the examples that are study in our third module is based on the European style. Whatever the concept we are going to discuss, and whatever the methodology idea that are required to reduce this, we are reducing this overload, we are discussed in the European style. Whatever the fluctuations, the load fluctuations, variations, voltage fluctuation, all these things are some necessary things I will study as a Europe perspective. So in regard to this, there are some of the low voltage, you can see voltage fluctuation, voltage imbalance we have seen, and also we see some low voltage effect. What are this low voltage which may cause us? So the most important characteristics is that the full load current for any devices should be stated, so that so whenever there is over voltage or under voltage, in such condition trip schemes can be installed, thereby we can protect all those consequences that are occurring. So in addition to that, we will see the permissible voltage drop in India. It is very necessary to know because we are the civilians of this country. It is very necessary to know this voltage drop, permissible range of voltage drop in our India. So according to this official guidelines from National Electricity Code published by the Bureau of Indian Standards in 2011, so then the acceptable value of this voltage drop under normal service condition, the voltage at the terminals of any fixed current using equipment shall be greater than the lower limit corresponding to Indian standard that is relevant to that equipment, where the fixed current using the equipment concerned is not a subject of Indian standards. The voltage at the terminal shall such as not be impair the safe functioning of these equipments. The requirements are deemed to be satisfied for a supply given if the voltage drop between origin of installation and the fixed current using the equipment which does not exceed 5% of normal voltage of supply. A greater voltage drop may be accepted for motors during starting period, and for other equipments with high rush currents are provided. It is to verify that voltage variations are within limits, within these limits specified, and the relevant Indian standard equipments are in absence of Indian standard in accordance with the manufacturer recommendations. So a training notes which is published by our Bangalore Electricity Supply Company, usually BESCOM. So while in the theory the permissible voltage variation should be within plus or minus 6%. Please do remember, so in your the UPSC questions or any civil service question, they may ask this, they may arise this question. You may see this question. While in the theory the permissible voltage variation should be plus or minus 6%, but in practical the supply voltage in many distribution system varies by 10% or even more. The voltage drop of 10%, which results in 10 to 15% increase in the load. A voltage drop of 10% results in 10 to 15% increase in the load current that is drawn by our induction motors as well. A decrease in the starting torque of nearly 19%, and increase in the line losses in the distributor will increase by 20%. Since most of the load in rural areas consist of the induction motors, because they are going to lift, they are used for the lifting up of water from the well, and also they are going to use that water for the irrigation purpose, so the lifting is necessary. For that purpose they will use the induction motor. Due to this, the line losses is concerned in distribution network, which may reach high up to 20%. So there is an article which is published by Indian Electricity in Indian Electricity Engineer General. The situation can be addressed by operating this load tap changers in a power transformer situated at 66 bar 11 kV high voltage substation and 33 bar 11 kV substations. By providing a combination of switched capacitor and automatic voltage regulators on 11 kV, we can mitigate this risk. And one more article which is published by International Electrical Engineering General. So this article states that with a title voltage profile improvement in an rural distribution network by conductor replacement. So this list values of a voltage drop. So this paper claims that during peak load, the time in some cases the voltage drop at a tail end sometimes reaches to 36%. The articles goes on suggesting that the voltage drop can be reduced by taking measures like implementing high voltage distribution system, taking an anti-theft measures, without 100% metering the energy account and audit will significantly reduced in this voltage variations or voltage fluctuations. So these are the some of the articles which are related to our Indian voltage drops which are given by Indian standards. So with this not taking much further, so I will conclude this small introductory part of this voltage magnitude variation. So thank you students. So this, since it is an introductory part for an voltage variation, so there will be no review question on it, no review question on this, or also no MCQ on this, but in general one should know what are the standards that are set by what are the standards and how this voltage fluctuation or voltage unbalance that takes place in the power system, and what are the measures that we have to mitigate these voltage regulations. Here in this module various methodologies are proposed that we will study in our forthcoming sessions. So I end up the session here. So thank you students.